Here we are being asked to express the equation this as a quadratic in terms of tan theta and hence solve it. So since we have tan A plus B format here and tan A minus B format here, we can use the identities for that. So tan theta plus 60 will become tan theta plus tan 60 divided by 1 minus tan theta tan 60. Similarly, it 2 plus tan 60 minus tan theta over 1 plus tan 60 tan theta. Okay, if we use our calculators, the exact value of tan 60 degrees is square root 3. So let's plug in this value. Let's see what happens. So tan theta plus square root 3 equal to 1 minus square root 3 tan theta equal to 2 plus square root 3 minus tan theta over 1 plus square root 3 tan theta. Okay, now we can see these are conjugates of each other. Can you see? So let's put them together and merge. Something will happen. So tan theta plus square root 3, 1 minus square root 3 tan theta minus square root 3 minus tan theta over 1 minus square root 3 tan theta equal to 2. And now let's multiply them with each other so that the denominator becomes same. That means this will multiply with this also and this will multiply with this as well. So first multiply the denominators, and which is in format of a minus b, and this was plus, oh sorry, this was plus, a minus b and a plus b format. So it will be a square minus b square. That will be the denominator. So now this multiplies here. So 1 times tan theta will be tan theta square root 3, then square root 3 tan square theta, and then plus complete 3 tan theta. Square root 3 times square root 3 is 3. Now let's multiply this here. Plus, there's a minus here, right? So let's put a minus and then multiply. Square root 3 minus tan theta, and then minus square root 3 and square root 3 tan theta will be complete 3 tan theta, and minus square root 3 times minus tan theta will be plus square root 3 tan square theta. Alright, since we have a minus here, let's see if we can subtract something. Yes, plus square root 3 and this is minus square root 3 because of this minus, they cancel out. Plus square root 3 tan square theta, and because of this minus, it will be minus square root 3 tan square theta, cancel out. Plus 3 tan theta, and this will also be plus 3 tan theta, so that will not cancel out. And tan theta and minus positive tan theta, so they will not cancel out. Okay, so the ones which are cancelled out are cancelled out, so let's do it written here. So this tan theta and this minus plus tan theta will be 2 tan theta. This 3 tan theta and this plus 3 tan theta will be plus 6 tan theta over 1 minus complete tan square theta, and that is equal to 2, which was here, which I missed in this step. Okay, so we know that 2 plus 6 will be 8 tan theta. And let's multiply this to the other side. It will become 2 minus 6 tan square theta, and let's bring everything to the left now. 6 tan square will be positive now, plus 8 tan theta minus 2 equal to 0. Let's simplify this by dividing by 2 all of them. So it becomes 3 tan square theta plus 4 tan theta minus 1 equal to 0. And now let's put this equal to A, this equal to B, and this equal to C in our calculators. And I get theta 1 equal to minus 1.54 and 0.215. These are the two values. So let's see this one first. What angle it gives us? What is our domain? Let's check our domain from 0 to 180. Okay. So we have to find answers up to 180 only. So in up to 180, tan is negative only here, right? So we'll put tan inverse 1.54. It came out to 57. So theta 1 will be 180 minus 57, which will be 123 degrees. All right. Second one, tan inverse 0.215. It will be positive in first quadrant because we have to go to up to 180 only. So tan inverse 0.215 will be 12.13 degrees. So these are the two answers. Here we have to express this particular expression in this format. So let's expand this format first. So it becomes r cos x cos alpha minus r sin x sin alpha by using compound angle identities. Okay, we have to find alpha, which is between 0 and 90. Okay, so let's write out this expression under this. So it becomes 0 square root 2 cos x minus square root 5 sin x. So if we compare the two, we can see that r cos alpha is square root 2. Can you see? Because cos x and cos x are in both. So r cos alpha equal to square root 2. From there, we see that r sin alpha is square root 5. Okay, so we want to find alpha. We can divide this equation by this equation. So let's write r cos alpha under this and divide square root 5 by square root 2. So right by right and left by left. Why? Because we want to cancel this r. Sin alpha over cos alpha is tan alpha, and this becomes square root 2.5. You can write it here. 5 divided by 2. When square root divided by square root, we can contain them inside a square root. Okay, so alpha will be tan inverse square root 2.5, and keep in mind, because they have said alpha is between 0 and 90, that means we have to just look at the first quadrant. Since we need to express this in 3 decimal places, it is 57.688 degrees. Okay. Now, they're also saying that find the exact value of r. So exact value of r cannot be possible if I put this angle in here and I get exact value of r. Not possible, because this will give me an answer in decimal. So best is that I square this equation. Okay, which will be r square cos square alpha equal to, that was square root 2, right? So square root 2 square. So r square cos square alpha equal to complete 2. Similarly, from the second equation, this one, we will get r square sine square alpha equal to complete 5, right? Now let's add both of them. What do we get? R square cos square alpha plus r square sine square alpha equal to 2 plus 5. So left added with left, right added with right. So we come, let's take r square common here. So cos square alpha plus sine square alpha equal to 7. We know this is 1. So r square equal to 7 and r will be square root 7. We will not write minus because they have clearly said r is greater than 0. So we got r and alpha both. Part B. This is part B where there is an equation that has the same expression we just simplified. That expression is equal to 1, but the angle has been doubled to 2 theta. So if our conversion was r, this one, cos x plus alpha, right? So in place of x, we will write 2 theta. That's it. So let's do it. So it becomes r. R was square root 7 cos 2 theta plus alpha equal to 1. This is the conversion. So we can divide both sides by square root 7. So this cancels here. So 2 theta plus alpha. Alpha is known to us now, 57.68. 57.688 equal to cos inverse 1 over square root 7. Okay, we have to see that our answer should be between 0 and 180, but we will not bother about it. We'll take care of this later. First, we will choose all 4 quadrants. Because of 2 theta, we'll come back to 180 as far as I expect. So let's start by 1, 1. So cos inverse 1 over square root 7. Let's see what acute angle it gives us. It came out to be 67.79, let's call it 8, 67.8. Okay, because it is positive, so this is the quadrant where cos is positive and this is the quadrant where cos is positive. So let's use this angle first. Okay, so 2 theta 1 plus 57 point, let's make this also as 7, equal to 67.8. So 2 theta 1 equal to 67.8 minus 57.7. Theta 1 is 10.1 over 2. Yeah, 67.8 minus 57.7 will be 10.1, and then because of divide this 2 divided by 2. Answer will be 5.05. We can write 1 because we rounded off these also, which were more than this sometimes. So 5.1 is the first angle. Second angle will be 360. 2 theta 2 minus plus 57.7 will be 360 minus 67.8. So 2 theta 2 will be 360 minus 67.8 minus 57.7 divided by 2, and that is equal to 117.3 degrees. So 5.1 is one answer and 117.3 is the second answer. And both are within our domain 0 to 180. Part A of the question is about an identity. Let me write the LHS again because we'll need to do something extra on this. So this is LHS. So now since our RHS has just one term, that means these two rational expressions must be merged to become one. And for that we have to write their LCM. And I will multiply this up and down by sin x and this one up and down by cos x, so that they have same denominator, which is cos x sin x. Okay, so what does this become numerator? It becomes cos x cos 3x plus sin 3x sin x. Okay, if we look at our identity, this will be cos 3x minus x. Or we can write x minus 3x also, looking at the sequence, but we know that cos minus x is same as cos x, so it doesn't matter. So I wrote the bigger angle first so that I get a positive angle. But we could have gotten a negative angle, that was no problem. The denominator looks like sine 2x, but 2 is missing here. We have an identity that sine 2a is 2 sine a cos a. And we have sine x cos x here, but there is no 2. So let's put a 2 here. That means we'll have to put 2 in front of this whole thing, and that's why this will be 2 here. And this becomes sine 2x at the bottom because of this identity. So now we are left with 2, and this is 3x minus x will be 2x. So 2 cos 2x over sine 2x, and we know that cos over sine is cot, which is RHS. Okay, let's move on to the B part. B part is also about the same expression, but here they have made an equation out of it. They're saying hence solve this equation which is equal to 4. So our this whole part is equal to 2 cot 2x. That becomes our equation. So it is equal to 4. So cot 2x becomes 4 divided by 2, which is 2. But cot has to be changed to tan. So 1 over tan 2x is cot 2x, okay, equal to 2. And let's switch their places by cross multiplication. So 1 over 2 equal to tan 2x, that is 2x equal to tan inverse half. Okay, our domain is from 0 to pi, but because the angle is 2x, we can use all 4 for the time being. So let's use it. Where is tan positive? Tan is positive in this quadrant and this quadrant. So let's write our first answer. Tan inverse half, which is in the first quadrant, is 0.46 radians. So x1 is 0.46 divided by 2, 0.23 radians. And the second answer of this one will be 2x2 equal to this angle, and this was 0.46, so this will be 0.46 here too. So that angle will be pi plus 0.46. Okay, and 2x2 comes out to be 3.14 plus this, which is 3.60, and x2 will be 3.6 divided by 2, 1.8 radians. And both the answers are within our domain. In this question, we need to convert this equation into a quadratic equation in terms of tan theta. So we already have tan thetas here, but we have a cot 2 theta that needs to go, and this angle needs to get separated. So let's get started. Tan theta will remain tan theta, and we can expand tan theta plus 45 as tan theta plus tan 45 over 1 minus tan theta tan 45, and 2 cot 2 theta can be written as 2 over tan 2 theta, because tan is the reciprocal of cot. Okay, so we know tan 45 is 1, so we'll replace that by 1. So tan theta plus 1 over 1 minus tan theta. Now we will substitute tan 2 theta with its value. So it is equivalent identity is 2 tan theta at bottom and 1 minus tan square theta and numerator. So because it's a reciprocal, so we write the reciprocal of the identity we have. Okay, we can cancel 2 and 2. So let's do the cross multiplication now. This tan theta multiplies here, 1 minus tan theta multiplies here. So we get tan square theta, tan theta plus 1. When this tan theta multiplies with this tan theta square. So 1 minus tan square theta here, and 1 minus tan theta comes from the other denominator. So now let's expand. Tan cube theta plus tan square theta equal to 1 minus tan theta minus tan square theta plus tan cube theta. Both sides have plus tan cube theta, so they get cancelled. Okay, let's bring everything else. Minus tan square theta and plus tan square theta, it will become 2 tan square theta, because this minus will become positive when it comes to the left side. This minus tan theta will become plus tan theta, and this one will become minus 1, and nothing is left on right side. This is the quadratic they wanted. Now we have to find the solution in the first quadrant only, 0 to 90 degrees. Okay, so let's factor this and we'll get something out of it. So let's assume tan theta equal to t. So 2t square plus t minus 1 equal to 0. So we can write 2t square plus 2t minus t minus 1 equal to 0. 2t taken common, t plus 1, t plus 1. So 2t minus 1, t plus 1 equal to 0. T is half through this. T is minus half, minus 1 rather, through this, which is tan theta is half and tan theta is minus 1. Since tan is not negative in first quadrant, so this answer is inadmissible. That means this is the only one we need, and theta equal to tan inverse half, which is 26.6 degrees.